let's say you want to organise a tournament, and in this tournament everyone is going to play everyone else once and only once. So this is a situation that comes quite a lot in chess. If you've got an even number of people, and that's what we're going to assume to start with, let's say you have 6 people in the group. Now it's very easy to organise the first round. For example, person 1 could play person 2, person 3 could play person 4, and person 5 could play person 6. That's round 1. And you can have all of those games happening at the same time. Round 2, we then have to have person 1 play someone different, because they played person 2 before, so they've now got to play either 3, 4, 5 or 6. However, we run into a problem if we start going down this route of sometimes when we get to the 5th and final round, where they have to play the last person, you get it so that multiple people have to play the same person. They all kind of clash. What we want is a way of picking these people so that no one ever has to sit out in a round. So for 6 people, we want it to end in 5 rounds with nobody sitting out. And there's a way we can do this. So let's have this as our first round. This seems as logical a place to start as any. So that's round 1. Across the top of this board, I've got written a set of permutations. So the way it works is this. In each bracket, we're going to take whichever player number we have. So we start with player 1, and we're going to go across and we're going to find who they're going to play against. So we find if the number is mentioned in a bracket, we find it, and we read off the next number in that bracket, but they loop around. So the next number in the first bracket after 1 is 2. So far we're at 2. That's our new number to carry on with. We now look at the next bracket, which is this one. 2 is what we're looking at. We're going to go to the next number in that bracket, which goes back to 1. So 1 is the number we're currently at. 1 isn't mentioned in this bracket, so we can skip it, as with the next one. 5 and 6 doesn't mention the number 1. And in this last bracket, 1 is going to go to 3. We're done now, so in round 2, person 1 is going to go play against person 3. Let's see what person 2 does. So in the first bracket, 2 is going to go into 4. So we're at 4. 4 isn't mentioned there, but it is mentioned there. 4 goes to 3. And now 3 goes to 5. So person 2 goes to place number 5. So if we've done it right, person 4 should be playing against person 6. Let's just check it. Person 4 is there. That goes to person 5. Doesn't mention 5, doesn't mention 5. 5 goes to 6. And then 6 doesn't go to anything in that last bracket. So 4 does go to 6. So it's managed to produce a different person each time, but actually as we go along, this is round 2, we can use a very similar bodge of this to give us rounds 3, 4 and 5. The way we do it is we count more than one place. So we're going to count more than one place on these edge brackets. Essentially what we're doing is we're putting another one of these in front of it, but you can imagine it kind of raising this to the power. So if I take a practical example, with 1 we want to find out what it goes to in round 3. We're going to go, here's 1, we're going to go 1, 2 places to number 4. 4 goes to 3, and now 3 goes 2 places on the other edge one. 1, 2. So person 1 is playing person 4. I'll do these a bit quicker now. 2 goes 1, 2 to 5. 5 goes to 6. 6 doesn't go anywhere. And then 3. 3, 1, 2 to 2. 2 goes to 1. 1 goes 1, 2 to 5. Okay? Similarly, I can do the same thing for this bracket and this bracket by jumping 3 places and then 4 places. Actually, this first round that we had fits into this pattern, and it's like we went 0 places in this. It's like the edge bits didn't matter. 1 played against 2, 2 played against 1, 3 played against 4, and so on. So it's like we have our power 0, 1, 2, 3, 4, and 5 to get all of our rounds. 0, 1, 2, 3, and 4. we can extend this system. So this works with 6 players, and it isn't actually that difficult to organise 6 people into the tournament just manually. But it's the first non-trivial one. Once we get to 8 or 10, it quickly gets quite big. So this came up in a chess tournament last year. We tried to do a Christmas blitz, all plays all, and we came across this problem just by we couldn't figure out how to get it where people didn't have to sit out. So I took it to the maths department at school, and Ali, who specialises in group theory, came up with this. But it's really neat, and you could program it up in Excel to get a tournament generator, which I think might be quite a useful thing to do. Just to put the general thing out there, notice how these go the even numbers, but we're missing 6. So in general, we're going to have 2, 4, ... all the way up to 2n minus 2, because it's going to have to be an even number here. We would kind of want it to go up to 2n, but we have to miss out the actual last player number. Then we go down with the odd numbers. So the biggest odd number is going to be 2n minus 1, and then we're going to go down until 3, 1. That's the first bit. The middle bits are just the same, so 1, 2, 3, 4, etc. all the way up to 2n minus 1, 2n. And then the last bit, I'm going to go onto another line, is this thing backwards. So 1, 3, all the way up to 2n minus 1, the biggest odd number, and then 2n minus 2, so not 2n, we're missing that one, but the second biggest odd, even number going down back to 4, 2. To get later rounds, we're just bumping powers up on these, which in permutations just means going multiple steps at once. It's neat. I realised I forgot to mention what to do with an odd number of people. So with an odd number, you just have a dummy. So pop one person in the tournament that doesn't matter, and it makes it into an even number. So you're going to have one person sitting out each round, but you had to because there was an odd number. That was mu.